Hey everyone, today I will discuss about solid geometry part 1. The module objective for this topic: after completion of this module, students should be able to number 1, define solid geometry. Second, explain properties of solid. Describe and solve rectangular parallelepiped. Define and solve cube. Describe and solve prism. Define Prismatoid and interpret and calculate solid geometry problems. Definition: solid geometry is the portion of geometry dealing with solids as opposed to plane geometry. Solid geometry is concerned with polyhedra, squares, three-dimensional solids, lines in three space, planes, and so on. Properties of solids: number 1 is volume. Think of how much water it can hold. Surface area. Think of an area to be painted. And how many vertices, faces, and edges. Polyhedron is a closed space bounded by planes. Rectangular parallelepiped. A polyhedron with 6 faces, which are all rectangles. So the figure shows the rectangular parallelepiped. Formula: for the volume, this is equivalent to length times width times the height, which is equivalent to volume equals to ABC. For the total surface area, so meaning all this area, you have here 1, 2, 3, 4, 5 front and the side 6, so 6 area. So this is equivalent to 2 times AB plus BC plus AC. So for the lateral area, so lateral area means this part, 1, 2, 3, and 4. So the 4 sides lateral area. Formula is 2 times BC plus AC. So we have an example here. The truck of Just Moving Company has an interior dimensions of 4.75 by 2.25 by 2 meters. The dimension of the storage boxes are 60 by 36 by 69 centimeters. If Just Moving Company needs to move 200 storage boxes, determine how many trucks will be needed. So for our solution, for step 1, we will have to compute first the dimensions of the interior of the truck and the volume. So here the dimension of the interior of the truck is given, 4.75 by 2.25 by 2 meters. So we can now compute the volume. So our volume is equals to 21.375 cubic meter. So step 2, we have to compute now the volume of the storage boxes. So with this given, 60 by 36 by 69. Using the same formula, we can get the total volume, and you just have to divide the volume of the interior of the truck by the volume of the storage boxes, which is equivalent to 144 boxes in one truck. So meaning we will need 2 trucks to move the 200 boxes. Cube. This is a polyhedron with 6 faces, which are all squares. The figure shows here the cube. So for the volume, this is equals to A cube. This is the side A. And the total surface area, which is equivalent to 6A squared. So meaning this is 6 sides, same side A. Then for the lateral area, so our lateral area here is this one, 4 sides, 1, 2, 3, and 4. which is equivalent to 4a squared. Okay, we have an example here. If one edge of a cube measures 12 cm, calculate for the surface area of the cube and the volume of the cube. So we have the choices here. So for the solution, surface area, so the given side here is 12 cm. So by using this formula for the total surface area, which is equivalent to 6a squared, you have 6 times 12 squared, which is equivalent to 864 square centimeter. And for the volume of the cube, we have here volume is equals to a cube, which are a is equals to 12 cm. So volume now is equals to 12 cube, which is equivalent to 178 cubic centimeter. So those our answer here is equivalent to letter A, which is 864 square meter, and the volume of 1728 cubic centimeter. Prism. This is a polyhedron having two faces which are equal polygons in parallel planes, and those other faces are parallelogram. So we have here right prism if the lateral faces are all perpendicular to the base, otherwise it is oblique prism. So the figure shows here the right prism. So the height is equals to the length. For the volume, area base times height. This one the base area, then the height. For the lateral area, we have here the perimeter B base here times the length or the height. For the total surface area, of course the lateral area plus the area here of the base, the two base. Okay. For oblique prism, this is the same as right prism but leaning. So here, so the difference is the height is not equals to length. So length is the slant height, where PB is equals to the perimeter of the base. So here, then the P slant is the perimeter of the right section here. Then area, right angle, so this is the area of the right section. Of course base area is here. Then L is equals to slant height. So for the volume for oblique prism, the volume is equals to base area times height, and also same with the volume is equals to area of the right section times the slant height, which is L. Then for the area of the right section is equals to perimeter times the length. So this is the perimeter of the right section times the slant height. Then for the surface area, we have here the area ng slant height plus 2 area of the base, which is from the bottom and the top base. So for truncated prism, so this is the shape. So we have different height of the legs. So for the volume, we can have area of the base, this one, times the average of the height. So here in our problem we have 6 height of the legs. So average of this 6 height here. We have a sample problem here for prism. The base of the right prism is a hexagon with one of its side is equal to 6 centimeter here. So the base are 12 centimeter apart, so our height is 12 centimeter. What is the volume of the prism? Then we have a multiple choice here so that we can check if our answer is correct. Solution. So first we have to draw the base of the prism, which is a hexagon. So here the given is 6 cm, then with the 60 degrees angle. So the volume of the prism is area base times height. So here we can derive from this given with 60 degrees angle, same length 6 cm for both sides. So using sine formula to get the area, we have here 1/2 times 6 times 6 again times sine 60 times 6. So we can get the area now, which is equivalent to 93.53 square centimeter. So for the volume, we need to compute the area base times the height, which is equivalent to 93.53 times 12. So our total volume now is equivalent to 1122.36 cubic centimeter. So this is letter D. Okay. Prismatoid. This is a polyhedron having 4 bases, 2 polygons in parallel planes, and 4 lateral faces, triangles or trapezoid, with one side lying in one base, and the opposite vertex or side lying in the other base of the polyhedron. So for the volume is equals to height times area 1 at the top plus 4 area 2 at the middle plus area 3 at the bottom divided by 6. So properties: the altitude of the prismatoid is the perpendicular distance between the planes of the bases. The midsection of the prismatoid section is the parallel to the bases and midway between them. Note that foregoing formula is valid for a much more extensive class of solids than prismatoids. Among the solids are included cones, cylinder, and spheres. In fact, the class of solids whose volume can be found by means of it so extensive that the formula finds wide practical application. Thank you. This ends our presentation for Solid Geometry Part 1. Our next topic is Solid Geometry Part 2 and will be uploaded separately.